Welcome to Chillin' 101. We hope this video helps.
In this video, I will explain how to use Cadence Genus. This powerful logic synthesis solution is essential for modern chip design. It efficiently transforms your register transfer level, or RTL, designs into optimized gate-level netlists. Genus helps you achieve your design goals by optimizing for critical metrics like area, timing, and power. It supports advanced technology nodes, ensuring your designs are ready for today's complex integrated circuits. To begin using Cadence Genus, first load your register transfer level design files. Next, specify your target technology library, which contains the standard cells for your chosen process. It is crucial to define your design constraints accurately, including timing requirements, area budgets, and power targets. Finally, ensure all necessary environmental variables are correctly set up for an efficient and error-free synthesis process. Once your design is set up, execute the synthesis command to generate the initial gate-level netlist. Cadence Genus then performs extensive logic optimization, automatically refining your design for better performance, power, and area. Carefully review the detailed synthesis reports to understand critical design metrics and identify any areas needing improvement. You may need to iterate on your constraints to achieve your desired performance and meet all design specifications. After successful synthesis, Cadence Genus outputs a comprehensive gate-level netlist and detailed timing reports. It is vital to verify this netlist against your original register transfer level design to ensure functional equivalence. Utilize static timing analysis tools to confirm that all timing requirements have been met, achieving timing closure. The optimized gate-level netlist is then ready for the next stage, physical implementation, moving your design closer to fabrication.
Thanks for watching. Consider subscribing if we helped you.